Hello. Alright, well, let's hope this video goes up by 7:20 now, so I can get through these 2-page exam in like the next maybe 20 minutes, and I can figure out how to post it online. Welcome to our video first ever. So practice quiz, which is Unit 4 packet, page 14 as I'm looking at it on the laptop. I'm going to go over the first problem, and we'll work it from there. Alright, okay. So, number 1. Sorry for being left-handed. I can't really start here at the far edge. It sets it over. Okay, a boy rolls his 3-kilogram toy truck at 2 meters off the edge of a horizontal 25-meter high bridge. How far away from the bridge will it land? Well, of course, you'll be able to use your notes on this quiz. It's not a full exam, and we did go over this question earlier today, but I'll start from the beginning. So as always, you should want to draw it out. Okay, cliff. I don't know, for some reason this kid is rolling his 3-kilogram car or object. Really what those mass is going to be not really needed. Is to throw you off, but what is needed is your Vx initial, which is going to be 2 meters per second. And of course, for some reason this small child is rolling off this car, and your height h is 25 meters. Who knows why this kid is standing next to a bridge 25 meters high alone? Well, how far away from the bridge will it land? Of course, how far is asking the question the distance in the x. Okay, so especially in the x. So a couple things here. Just like in class, I'll make our y initial equals 0, our final y position equals negative 25 meters, our x initial will equal 0, and of course our final x position is what we're trying to figure out. So a couple things in this problem is, of course, you have to figure out how long it'll take it to fall. Once you figure out how long it takes to fall, then we can use the velocity x and the time to then figure out how far it goes. Okay, since we need t first, this is totally in the y-axis and y-axis only. So I'm going to start with the equation y equals yo plus vot plus 1/2 at squared. Now, of course, this is in the y-axis. I know a couple things like VO equals 0 initially in the y, 0 meters per second. So I also know my initial conditions. So I know how long, I know it's going to fall, negative 25 meters. I know my initial y position is 0. I know my initial velocity in the y is 0 times t plus 1/2 at squared. So eventually this becomes negative 25 meters equals a negative 9.8 divided by 2 t squared. A negative 25 meters equals a negative 4.9 t squared. Of course, both sides, negative 25 divided by negative 4.9 equals t squared. This is very similar to the equation we came where t equals the square root of the height divided by 4.9. This is the equation we came up in class earlier today. Let me scroll up. So ultimately, I'm going to get 25 divided by 4.9 equals 5.1. So 5.1 equals t squared, square root both sides. T is going to end up equaling the square root of this answer here. That's going to be 2.26 seconds. Okay? So ultimately, I can bring that back to the top and use my equation. Since I know my acceleration, the x equals 0, then I really get the equation x equals xo plus vot. And since my initial xo was 0, I can get x equals 0 plus my vo is 2 meters per second times 2.26 seconds. Well, my x position is going to be times 2 equals 4.52. 4.52 seconds. will be my final x position there, and that's number 1 in a nutshell. Okay, make sure you have these notes ready to go, because really what I'm going to change is the initial horizontal velocity and also the height, my y. So a couple of these other changes, but the format will still be the same. Alright, let's move on to number 2. Number 2. A baseball player hits a foul ball straight up into the air at 30 meters per second. So I know that my initial velocity is straight up, VO in the y equals 30 meters per second. Okay, how long will it take it to land? Okay, so a couple things. I know it's going to go straight up, and then it's going to come straight down. So your V final in the y is an equal to -30 meters per second. Assuming that hitting straight up and hitting straight down, that's what we're considering, going straight up and then coming back straight down. Okay, so with that equation we can get V equals VO plus AT. Once again, since it's just in the vertical, my acceleration is entirely in the y equals -9.8 meters per second per second. So my final velocity in this case is going to be -30 meters per second. My initial velocity is a +30 meters per second, and my a is going to be a minus 9.8 meters per second times t. I'm just doing that to show the units, but then I can take it out. It goes -30 equals a +30 minus 9.8 times t. So if I bring this over, I'm going to get -60 equals -9.8 times t. Dividing both sides, I'm going to realize that the negatives cancel out. So 60 divided by 9.8, that's going to be a 6.1 seconds. Total flight time is 6.1 seconds. Great. Well then, how long does it take to its maximum height? Well, the maximum height essentially would be half the time, because the full time would be 6.1 seconds. To get halfway up would be half of that time to the maximum height. Well, that would be 6.1 divided by 2, 3.06 seconds. So I'll put that at 3.1. About 3.1 seconds. Why do I want that? Because if I can plug that in, I can figure out my max height, which was entirely once in the vertical, since I'm working with height. I'm entirely going to work on the y-axis. So y equals yo plus VOT plus 1/2 AT squared. Of course, my initial y position is 0. My initial y velocity is 30 meters per second. The time to get to the max height, as we estimate as half the time, would have been about 3.1 seconds, plus a 1/2 times a -9.8 meters per second times that 3.1 seconds squared. And so I'm going to get a final value for y. If I plug this in correctly, what do we get? Let's see how I do this. 30 times 3.1. Whoa, what happened to the light? Hello? Is there a light here? Make it brighter? I hope you guys can still see. Is it still capturing? Is it still recording? Yes, it's still recording. Alright, cool. I do not know what happened to the light. Oh. It must have gone out. Really? Hello? Alright, so we'll go with natural light. I hope that you guys can still see naturally. Okay? I'm trying to write big. Let me know, give me feedback on this video, please. 30 times 3.1 plus, I'm going to put parentheses, I'm going to change the 1/2 to a 0.5 times a -9.8, which I really know is like a -4.9, but I'm just going to plug it in, everything in, times 3.1 squared. Okay? And so, this is going to go straight up 45.911. I'm going to round that to 45.9 meters. You can round it to 46 if you want to, but then that's the maximum height of this object that was launched upwards at 30 meters per second. Now C. Sketch a graph of the velocity versus time and height versus time of the object and state what the slope of each graph represents. Well, let's think about this. If I really think about this, and this is part C on this problem, velocity versus time. Well, I start with a positive 30 meters per second at time 0. And since I do know that the slope of velocity time graph equals acceleration. Yes, my friends, I've repeated this many times again, that means that every second I tick, and since my acceleration equals negative 9.8 meters per second, this is the reason I write this in this way, meters per second, that this is units of second, this is meters per second, every second, this is going to tick off by the negative 9.8. I'm just going to make it easier, so I'm going to round it to negative 10 meters per second in our case. So now this is going to be 20 meters per second. After 2 seconds, it's going to be 10. After 3 seconds, it's going to be 0. Oh, velocity went all the way to 0. Means that it slowed down. And if we look back here, that matches about the fact that in about 3 seconds, 3.1 or 3 seconds, I reached my max height. Now my velocity is going to be negative as I'm falling back down. Well, after 4 seconds, it's negative 10. After 5 seconds, it's negative 20. And after 6 seconds, it's negative 30 meters per second. And right there, ladies and gentlemen, you have a beautiful plot. Over 6 seconds, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And since I have these line graphs here, okay, I'm going to really do a scale of 10, 30, 20, 10, negative 10, negative 20, negative 30. I can plot it. Look at this. Look at this here. Look at this here. 3 seconds is 0. 4 is a little bit out. I'm sorry for that. That's a really weird scale. I'm just going to make this 4, 5, 6. Oh, that's better. Right here. 5 is there. 6 is here. Look at this. Look at this nice straight line with what? With a slope that equals a negative 10 meters per second. That matches the acceleration. Beautiful. Now, the height versus time. Whoa. That is tougher. This is velocity versus time. You know, think about it. Well, I mean, it's actually not that bad. Versus time. Of course, you're going up, and you're going to come down. You should be back at 0 at time. So there's some 0 points here, 0 points here. And I'm not going to use certain points. 1, 2, 3, 4, 5, 6. Well, I'm only going to use 3 main points to do a sketch. Okay. I know that at 3 seconds my maximum height is 46. So at least I can go up to 46. Also use a scale of 10. 10, 20, 30, 40, 50. So at 3 seconds I'm at 46, so it's right about here. Okay. And then, I mean, obviously it's going to go up and back down. This is a good sketch. Decent sketch. Notice there's no negative since the ball's not going to go into a negative at all. So this is distance versus time. Now this makes sense because your slope is actually changing. And we learned in class, your tangent line is a line that's just at the tangent point here. So you can see here, if I look at this, after 1 second, if I look at the slope right here, it's really in 1 second 30 meters per second. It's going to switch over to 0 because at 3 seconds my velocity is 0. That's the slope here, 0. At 6 seconds it should really be negative 30. And so essentially, I mean, this is a rough sketch, but this is pretty good. Once again, on this graph, the slope of a distance time graph equals velocity. And you can see the actual slope of the tangent line at these three main points where it was launched, 6 seconds it took to get back to where it was launched, and right at the halfway point when it reaches max height, according to our math on the prior page. You can rewind a few seconds for that. These velocities do match the velocities at these certain time points. Positive 30, 0, negative 30. Not bad. And that's number 2, ABC. Whoo. Let's go over number 3. Number 3 now. Number 3 now is really giving you at an angle. So, my original velocity is 20 meters per second. This is going to be 30 degrees. Okay. And of course, I have my velocity x component, velocity y component that gave me the resultant. You know what? We know what we got to do here. We do have to find Vx and Vy. Now, since part A is asking for the max height, we know that height is the y-axis. So I'm really going to start with solving for Vy. Vy equals V sine theta, which is going to be a 20 meters per second times a sine of 30 degrees. Sine of 30 degrees, off the top of my head, is 0.5. So it's 20 meters per second times 0.5. That's what's studying those tables with the angles and your trig functions comes in handy. 10 meters per second, and look at that, just as that. So I know my initial y velocity is 10 meters per second. Guess what? Once you figure this out, it is the same process back here. What is your initial y velocity? But in this case, your initial y velocity is no longer 0. Your initial y velocity is going to have something. So, I'm going to go the easier route, maybe on problem 2. Find the time it takes to reach the top of this trajectory, because I know if I'm starting at a positive 10 meters per second, the y-axis, that's a positive 10, then when I reach my maximum height here, my velocity is going to be 0 meters per second. If I can find that time, then I can plug that time back into the y position equation. So let's do that. It's a two-step problem. So V equals VO plus A times T. Since again I'm in the y-axis, let me just know some things for the y. A in the y equals a negative 9.8 meters per second y-axis. The only acceleration is in the y. So my final velocity I want to reach is 0. My VO that starts with is going to be 10 minus a 9.8 times T. Beautiful. I just plug things in. I'm not going to do units. I know I've been annoying about it, but I'm trying to save some time in this video. So I get negative 10 divided by a negative 9.8 equals T. Look, I was about to use my calculator. That makes no sense. I'm going to round this to 10. Negative 10 divided by 10. Guess what? It reaches maximum height. I'm going to round T to about 1 second. That's not going to work in the case I'm going to change these numbers for the actual quiz. But once I figure out the time it takes to reach that max height, when my velocity is 0, then I can go backwards and plug that into y equals yo plus vot plus 1/2 at squared. Of course, your initial y position is 0. Your initial velocity in the y is a positive 10 meters per second. Your time is going to be 1 second. Plus, I'm running out of room here, so I'm going to say that's a minus, since I know that a is a negative, and times a half. So this is 1/2 times 9.8, a minus 4.9 times that 1 second squared, but that's just going to be 1. So here's what my max height is going to be: 10 times 1 minus 4.9 times 1, since 1 squared is 1. And what's going to be? That's 10 minus 4.9. What does that equal? Well, that's 10 minus 5 is going to be about 5 meters. This arrow only goes about 5 meters into the air. Upwards on the vertical. We're done. Remember, this is a 2-step problem. Well, 3 steps actually. You need to find Vy initial. The component is Vy. Figure out when that equals 0. How long it takes it to reach that max height. Then you can plug in that timestamp into the position equation, making sure that you keep your initial conditions consistent according to the problem. And that was number 3. Bam. Let's continue on. 4 through 7. Oh, and we're done with this quiz. Ladies and gentlemen, yes, we are. Look how easy this is. If you study this video, you'll be ready for this quiz. If you don't, then I don't know what else to do to help you. This is literally me going over the quiz. I'm just changing the numbers. Study this video, practice it, be ready for tomorrow. Arrange each section A, B, B, C, etc. in increasing magnitude of acceleration. Wow! Let me just do the sketch of the graph here since you can't see it, and I lost my copy of it. Otherwise I would be doing it on the actual copy, but instead I'm doing it in this notebook. Okay, so this is a velocity time graph. Guess what? The slope of a VT graph equals acceleration, people. So they want the rankings in order of increasing magnitude of acceleration. Well, guess what? I already know the slope here. The slope here is 0. B to C is 0. A equals 0 for segment BC. That's done. That's the first one. Now I can figure out which ones are greater. I find the slope. Here, remember, I use my data points. This is data point 0, 0. This one, according to the graph, is 1060. This one is a little bit over, still at 60 in vertical. It's going to be 1560. This one down here is going to be 40, negative 40. And this one here is going to be 55, 0. So, oh, who's texting me? That's my brother. Hold up. Don't look at my text. Okay, so I really can quickly calculate these slopes. Guess what? This is in this one, my delta y equals 60 minus 0, so that's the delta y of 60. My seconds x, my delta x equals 10 minus 0, that's a 10. This is a slope of 6 meters per second for this segment here. In this case here, my delta y equals a negative 40, my y2 minus my y1, negative 40 minus 60. That's a negative 100, and that makes sense because it goes down 100 in the y. In the x-axis, it's 40 minus 15, and that's always going to be positive since time continues in positive direction. 40 minus 15, well, that's 40 minus 5 is 35, 25. That's what? Well, it's 100 divided by 25, that's negative 4 meters per second per second. That's this segment. And this last segment here, you're going to go 0, y2 minus y1, my delta y over delta x equals 0 minus a negative 40. That's a positive 40, means I went up 40 in the y, and then I went over 15 seconds. Well, I already know 45 divided by 15 is 3. That's a little bit less than 40, so we need a little bit greater than 3, but it's not going to be greater than 4. 40 divided by 15 equals 2.66. Oh, it's a little bit under. I messed that up. 2.67 meters per second per second. And so, if you really look at this, and you need to do the math to prove your point, 0 meters per second per second. My segments in increasing order of acceleration would be segment BC, that's 0. Then it would be segment C, D, E, F. Well, segment C, D, E is all one constant line. So the next one would be E to F, segment E to F. The third one would be segment C, D, E, since that's a constant line here. And yes, even though it's negative, that just indicates a direction. It's still greater in magnitude than the change here in velocity. Okay, the negative does not mean greater or less. The negative just means direction. So this is just a 4 being compared to 2 plus 6, 7. But this 4 is still less than this greatest magnitude, A to B. And to be honest, you didn't need to do the math if you could have just recognized from the graph that this was steeper, this was not steep, but it's too close to call, so doing the calculations does help. So let's finish this up with 5. Identify the point or section which the car is returned to its original starting location. If it does not return to original location, explain how far it is and how do you know? Oh my god. Well, ultimately, this is the part that the area under the curve equals displacement. Now this is interesting because I'm going to have a positive area and a negative area. If these two cancel out, bam, then I've reached home. So let's figure this out. This up here is going to be a, what is this, 5 seconds here. This is going to be, well, this is at 30. Yep. So this is going to be 30 down here, and the height is going to be 60. Well, I know that I can calculate the entire area here as a trapezoid, which is 1/2 base 1 plus base 2 times the height. My base 1 is 30, my base 2 is 5, my height is 60. 1/2 times 35 times 60, which equals 30 times 35, since I multiplied the half times 60. 30 times 35 equals, well, he moved in a positive direction, positive 1,050 meters. Now let's see what happens here on this segment. On this segment, it is a negative 40. It's negative. And this goes from 30 to 55. 30 to 55. So this span is going to be, what's 55 minus 30? That equals 25. So in this case, this is a triangle, base times height times 1/2. 1/2 base times height, 1/2. My base is 25. My height is 40. 0.5 times 25 times 40 equals a negative 500 meters. Guess what? Does he ever get home? No. He does not get home because he went, for this first part, this area on the curve indicates that he went 1,050 meters forward. This part of the curve in the negative indicates that he went a negative 500 backwards. So how far is he away from home? Well, I just add these two values and I can figure out, because home essentially would be his starting point. 1050 minus 500 equals, he is 550 meters from home. Boom. And we're done there. Describe in words the motion of the car through each section. Well, I mean, once you calculate the accelerations, I'm not going to write this out. I mean, you could literally just, or you will have to for the quiz tomorrow, but for the first segment, he's driving acceleration of 6 meters per second. So he's moving, he's increasing positive velocity. Then he's moving at a constant velocity. His acceleration is 0, but he's still moving forward at a constant velocity. Then he's decreasing his velocity at a constant rate. Then he goes back to increasing his velocity to 0. I mean, here he stops. When it's 0, he's literally stopping. So this moment, he's like slowing down and then going in reverse, or just going in the opposite direction. However you want to frame it, but I'll leave that to you for number 6. Can't do everything for you on this video. And number 7, draw the corresponding acceleration versus time graph. Oh my god. Guess what? My acceleration from 0 to 10 seconds is a constant 6. Then it's 0 from 10 to 15 seconds. Then from 15 seconds to 40 seconds, my acceleration is a negative 4. Then from 40 seconds, 55 seconds, it's a positive 2.67. So if I'm really doing an acceleration versus time graph here, I'm saying for the first 6 seconds it's 6. well, not the first 6 seconds, first 10 seconds. So this would be 10. Then it's 0. Then it's -4 for that. So you see, I'm showing the acceleration is constant at certain values for certain time frames. This is how you do number 7. I tapered off here to the end because I'm trying to keep it to a 30-minute video. Ladies and gentlemen, good luck studying tonight.